My name is Gautham. I'm a front-end engineer in Atlassian. I'm part of the UI platform team. So Dhaval, who spoke before, so he's my manager, and I'm going to talk about one of the projects that we did. Um, the responsibility of our team is to improve the developer experience of the monorepo that we have in Atlassian. And one part of that is to improve the CI performance for the type check job that we have. A quick show of hands. How many of you know about project references in TypeScript? Okay, not many. So that's good. You learned something new today. So what is project reference? So traditionally, the way type checking happens is regardless of your change of your PR, type check does the type checking on every file in your repository. But at some point, as your repository gets bigger and bigger, that cannot work, and you need to break it down into much smaller pieces. So this is a feature that TypeScript has itself supports from 3.9 or some version. So basically, what it allows you to do is it lets you break a large TypeScript project into much smaller TypeScript projects. With also doing that, the next thing that also allows you to do is help you do incremental builds. What that means is, say the first time you do type check, it does type check on all the files in the repository. The second time, what happens is type check is smart enough to know what are the files that have changed since the first run has happened, and then only do type check on the changed files. So this is a very big feature in itself for folks who have big monorepos, where say you change just one line and raise a PR instead of waiting for like 20-25 minutes, you are able to do your type check in a much faster time. Another advantage that you also get with project references is that it improves your IDE experience. If you enable project references in IDE, you will load much lesser files into memory, which means the TS server will be much more ready for you to show all the IntelliSense data or the tooltip data that you can see in your IDE, and which also means that you don't need to wait a lot before you start coding. So let's start with like a traditional configuration on how TypeScript would have been configured. So this is a sample monorepo. So here you can see there's just one TS config at the root of the repository, right? And if you look at the config itself, so you can see that it includes all the packages, it excludes node modules, and it extends base.config for like generic properties. Now, with project references, what you have to do is you need every package needs to have its own tsconfig.json, and you also need a root level tsconfig.json. So now let's see how the package level tsconfig.json looks. So this is how it looks. So you can see the include has changed. You can see that it only includes all the source files. Composite true. So this is a special property that tells TypeScript that this is going to be a project referenced project, right? And if composite is true, you need to make declaration also as true. So what that means is with project references, when you do type checking, you will get dist files for your actual project. The third property is declaration map. So this is a property that helps the IDEs to actually navigate to the original file instead of the dist file. The other main property is references. You need to tell TypeScript what are the dependent projects that your project is dependent on, so that TypeScript can do the type checking in an incremental way. We'll talk more about that later on. So this is the root level TypeScript config. So here you can say the files is empty, include is also empty. And then the references, you need to list all the references or all the projects that you have built in your, or that you have configured in your repository. So let's see how that works. Let's say there's a special -b parameter. So that enables the build mode for TypeScript. So you need to run yarn tscb tsconfig. If it's the first time, you can see that it is building both the projects, right? Foo and bar, because there's nothing for it to reference against. Once you run, this is what happens. You see the dist file for each of the dist folder for each of the packages. You can see it has outputted the d.ts file, and then there is a special file called tsconfig.tsbuildinfo. So that tells TypeScript on whether a particular project has to be rebuilt or not. So it has some metadata that Typescript understands it and it reads to decide whether a specific project has to be rerun or not. So now let's look at the second time you run. So let's say you run it the second time without any change. So you see that log that the project is up to date. It means it does not do type checking the second time because it knows that there's nothing has changed since the previous run, and it just exits. Now, let's say you make a change in bar. So here you can see the first line. You can see foo is up to date because we don't make any change in foo. So type check does not do any type checking on the foo package. The second one, you can see that bar is out of date. It basically knows that bar has changed since the first time, and then it just rebuilds bar alone. So this is the power that you get with project references, where you are able to incrementally do type checking. Except uh, you know, with this, the talk is over, right? Like, maybe you do all these configurations in your project, in your monorepo, and then you're done with, right? So, you cannot simply implement project references on a huge monorepo, which has a lot of history without dealing with package cycles. Let's see what a package cycle is. Or before that, I'll tell you why is package cycle a problem. Typescript, when it tries to build all these packages, it does a topological sort. It basically first finds the projects which does not have any dependency, builds them. The next iteration, what are the packages where I have built all the dependencies, and I run that, and then incrementally, right? Standard topological sort. But then when you have cycles between packages, then you just can't do topological sort, and then Typescript fails. So a package cycle is when package A depends on package B and package B depends on package A. So it doesn't have to be involved with just two packages. It can also involve multiple packages. So we also found, with respect to a front-end monorepo, we found two different type of cycles that were here. One is an app cycle, another is called a dev cycle. An app cycle is what we consider as a cycle which is caused purely due to dependencies. A dev cycle is something which is caused due to dependencies and dev dependencies. We'll go in more details on what this is next. Yeah, so this is an app cycle. So imagine you have two packages, common utils and issue view. So common utils directly has a dependency on issue view, and issue view has a direct dependency on common utils. So this is something that we call as an app cycle, and this has to be broken before you enable project references in your repository. A dev cycle, on the other hand, is something like this, where issue test utils requires issue description as a direct dependency, but then issue description requires issue test utils as its dev dependency. Because it's not a pure dependency cycle, we call this as a dev dependency cycle. So when we started, we had around 130,000 of these package cycles in our owner repository, and we had to break all these cycles before we actually start implementing project references. How do you do something like that in that scale? Is first you identify the cycles. You use package.json as your source of truth. So you have to have a comparison with package.json and a graph, right? So you can assume a particular package as a node, and then a dependency mentioned in your package.json as a edge from your node. So with this, you build an entire dependency graph for your particular mono repository, and you use your package.json as a source of truth. The second thing is you need to run a DFS or a BFS. Now you have your entire graph, you run a DFS or a BFS and find all the list of cycles. You also need to save whether a particular dependency is due to a dev dependency or a dependency. This information is helpful later on. We'll talk about that a bit later. So here are some examples that you can see. Packages of length 3 to 4 and multiple things, right? So these are, so you can see some. The first one is a pure dev dependency cycle, the pure dependency cycle, and the next one is a dev dependency and dependency cycle. Now you need to fix 130,000 of these. How do you do that effectively? So what we analyzed in at scale, you find some commonalities between certain cycles. So here you can see, though they are two different cycles, you can see that the foo being dependent on bar is being present in two of these cycles, which means that if you are able to break the link between foo and bar, you break two cycles. So this is at our scale, we found these kind of links, which you break a single link and that breaks like thousands of cycles, right? So what we had to do is, first we had to group all these cycles based on these common links. Then we have to build tooling so that we can display all these group cycles so that developers can look at these cycles and then break them. So you can't fix all the cycles by yourself. So you need to have your product teams to fix all these cycles. So you need to assign all the group of cycles to a particular team. You can do that by creating tickets. So you tell them, hey, this is all the cycles that comes in your team's purview, and we want you to fix it. And then you track it based on tickets. Now, these things takes time. It typically takes around 2 to 3 months for teams to fix all these cycles. At the meantime, you also need to prevent new cycles from coming in, because people might create PRs where you keep adding all these new cycles, and it becomes an infinite loop where you never get to zero cycle thing, right? So this is where we use a tool called ratcheting. So ratcheting on a very high level is it prevents new violations from getting introduced to the repo. What is a violation? A violation can be anything. So for example, usage of style components. How many times the style components is being imported? So that's a count, right? So maybe you want to stop people from importing style components, then you add a ratcheting rule against that. So how it does that? It uses a merge-based commit to compare the violation from your master branch to your feature branch. So what is a merge-based commit? So the common base commit that you see here is the merge-based commit. So effectively, that is the commit from where you actually created your branch from master. So how do you do that? So what you use your merge-based commit, you find the number of violations in your merge-based commit, and then you also find the number of violations in the latest commit in your feature branch. So that is the condition. So if the number of violations in your feature branch is higher, that means that you are actually introducing newer violations to the repository, which you don't want to do. So you break the build at that point. If it is lesser or it is equal to, it means, okay, you haven't added more harm to the repository, so you are allowed to merge up here. For cycles, we added a new rule. So basically what we do is we count the number of cycles in the feature branch in your latest commit. And then we also check out the merge-based commit, find the number of cycles in the merge-based commit, and then we compare these two numbers. If your PR has introduced more cycles, it means you can't merge your PR and the build breaks. Another thing that we also found is there were some valid cycles that developer wanted to have because of certain patterns that they used in the repository. So this is one such example. Issue test utils is like you can assume that it is like a common package where all the different mocks have been like organized together so that like different packages can use them once, right? So here you can see issued comment and issued description. They are like proper packages which actually use issue test utils. So here you can see that issue comment depends on issue test utils, and issue test utils, on the other hand, again depends on issue comment because it needs issue comment to build the comment mocks that it has to export. So one thing that you notice here is this is not a proper app cycle, it is a dev dependency cycle. So this pattern we wanted developers to continue have because we felt it makes sense. So we started looking into options on how we can allow developers to have these cycles, but also implement project references for the repository. So that is where we came up with the concept of app and dev tsconfig. So I'll tell you what an app tsconfig is. This app tsconfig will include only your app files. And it includes any of your dev dependency, right? Like test files, storybooks, examples. Dev tsconfig, so that includes, it's the opposite. It includes only the test files, storybooks, and examples, but it excludes all the app files. So app files here is like all your actual source code, which will get landed in the browser. So let's look at an example here. So if you remember, previously there was just one tsconfig, but now here you see that every package needs to have two tsconfigs. So one is tsconfig app.json and the tsconfig dev.json. So this is an example of a tsconfig app.json. You can see that you include all the source files, but then you exclude test files and example files. So this is an example of dev.json, where you can see that it includes the test files and example files that were excluded by app, but then you exclude the actual source files. So it's the other way around. So that way you have type checking on all the files, but then it's split out. So now let's see how this helps us break the cycle, right? Previously, if you had just a tsconfig.json, so if you remember the references where you need to declare your dependencies for project references, so issue test utils would say, hey, I need issue description first to be compiled before I can compile myself. And issue description would say, I need issue test utils to be compiled before you can compile myself. So this is the cycle that was there previously. So look, also an example, just see how these issue test utils config looks like. So you can see in the references, the issue test utils references to the issue description, and the issue description config refers to the issue test utils. So this is a cycle that I was talking about. So now with the split of app and dev, you now have 4 projects, right? So test util has two projects, app and dev, and issue description has 2 projects, app and dev. So let's take a let me explain this a bit. So the 2 vertical lines that you see, the tsconfig dev, depending on tsconfig app. So that is because you want your dev files to depend on app files, because of course when you write tests, you need to import your SRC files, right? So that is the reason those 2 horizontal files are there. The 2 vertical, the first one, let's start with the first one, is the tsconfig app.json. For issue test utils has a dependency on issue description. That is because it requires issue description to build its test utils, right? And then the other one is the tsconfig dev.json of issue description requires issue test utils. And that is again because you want issue test utils for your tests. So you can declare it as your dev dependency. So let's look at the content of these packages, of these configs. The tsconfig app.json for issue test utils, it depends on issue description, like we saw in the image before. The second is the dev.json for issue test utils. So that depends on its own tsconfig app.json. That's because if you want to write a test, you need to have a dependency on your SRC files. The next thing is the description for the issue description. So this is a leaf level package. So it does not depend on anything. So the references is an empty array. The next thing is the issue description tsconfig dev.json. So here it depends on 2 things. One is the app.json of itself, and then the issue test utils is tsconfig app.json. So you need the app.json because again, you need to write tests based for your source files, and then you are using something related to issue test utils. So you declare that as your dependency. So now let's see what will be the compilation order in TypeScript. So you can see that, let's see, the first one would be the issue description app.json. Because it is a leaf node, it doesn't have to wait for anything, and TypeScript will automatically, just build that for you, right? The second thing is the issue test utils. So here you can see that all the dependency of issue test utils has already been built before. In this case, it's just the issue description. So that is the next candidate for the TypeScript to do the build. After this, the next compilation will be the 2 dev.jsons, which is again because all of its dependencies have already been built. So TypeCheck will now be able to build and compile all these packages. So you can see that with all these cycles present, we were able to break these, not make these cycles visible for TypeScript, and also be able to implement project references in our repository. So now that we are able to implement project references in your repository, the incremental thing, right? How do you do that in CI? So in CI, every time it's a fresh build, you don't know what happened before. So every time, how do you utilize project references in the CI? So this is an older slide. So just remember that when you run TypeScript in the build mode or the project references mode, that you get the dist files which get executed, right? So these are the files that are a result of you running project references. So what you need to do first is on every master commit, run the typecheck command. So this will the typecheck will run and it will output all the dist files for you. So you need to zip all these dist files and then push it to remote, right? An S3 or whatever bucket that you have. And you also need to key it based on the commit on which the type check was actually happening. The second thing, on your feature branch, before you do your type checking, you need to pull the cache that you had pushed on master. So you know what is the merge based commit between your feature branch and your master branch. And with this merge base commit, you see in this in S3 or whatever storage that you have, right? Hey, is there a cache that is available for you to pull? So you pull that and then you unzip it before you run the type check command. Then now you run the type check -b command, right? So now that you have unzipped that cache and then it is there in the CI, type check doesn't care. It knows that, oh yeah, okay, type check has already been run before. So maybe let me just reuse whatever I had done before and then let me just do type check again. So in this case, since you are getting the cache of your merge base command, the only change packages for you will be the change packages in your repository, right? So if you made changes to just one file, so that is the only project that TypeCheck would know has changed. If you have made changes to like 10 or 15 packages, so those are the only packages that would incrementally build. So with this, we were able to implement project references and we were able to see a very good gain in our CI for the type check time in our model repository. That's it.